this tutorial, we'll be dealing with attachers, meaning we'll be looking at tow bars and three-point hitches. In doing so, we'll also learn how to automatically readjust the alignment of objects. Cylinders are most commonly used for this application, either on the three-point hitch of a tractor or on the tailgate of a trailer. In this section, the couplings for trailers are set. Each coupling must have an index attribute. This attribute points to a transform group in the i3D file and thus sets the position and orientation of the coupling. The orientation must always be selected so that the x-axis points to the device and the y-axis points upwards. Some couplings can be adjusted in height when being attached. For this, we need to specify the transnode attribute, which is a parent object of the index attribute and therefore of the actual coupling point. The minimum and maximum position of these objects can be specified with a transmin y height and transmax y height attributes. We can also set how much play the equipment attached to the coupling should have with a max rod limit attribute. For this, 3 values are needed to define the degrees of freedom around the x, y, and z axis. Finally, we can define a power takeoff shaft by specifying the attribute PTO output node, which corresponds to the transform group to which the power takeoff shaft is connected. We specify the power takeoff shaft itself, or rather the model of the power takeoff shaft, with a PTO filename attribute. The path specified here has a $sign at the beginning and points to the installation directory of Farming Simulator. In the attacher joints section, we can define 3-point hitches. In addition to the attribute index, 2 rotating objects, nodes or transform groups can be specified. They are called rotation node and rotation node 2. Rotation node is located on the vehicle directly at the starting point of the coupling. Rotation node 2 is used to keep the device approximately parallel to the ground. It's usually found in the same place as the coupling itself. The rotational values of these 2 points are defined with the attributes minrod and minrod2 when the device is up, while maxrod and maxrod2 specify the rotational values when the device is down. In the lowered state, the attacher needs some clearance so that it is not completely and rigidly connected to the device. The clearance should include room for both a translation and a rotation. The entries for this are called max translimit and max rod limit. This procedure allows for degree adaptation of the device relative to the current ground structure, preventing it from getting stuck on uneven terrain. The move time attribute defines the time it takes for the hydraulics to move fully up or down once. A 3-point hitch usually has moving parts that need to be specified if they are to move. With bottom arm, we set the lower arm. Here we have a rotating part which rotates so that the arm always has its z-axis pointing in the direction of the device. Next, there's the moving part, which is a child of the rotating part. This is always shifted so that the reference node point lies directly on the coupling point of the device. We define the upper link with the attribute top arm. Here we use a further i3D file which contains the relevant data. Next, we specify the index where the upper link should be located. The 3-point suspension has other moving parts which move with the lower link. There's also the option of defining cylinders and other aligned parts. First, we set the moving part entries for the appropriate parts. They consist of the index attribute, which defines the object itself, and another object called reference point, which defines the object towards which the object index should turn itself. The orientation of the cylinder is then always such that the z-axis of the object points in the direction of the reference point object. However, the reference point only fixes the direction of the z-axis. The cylinder can rotate freely around this axis. To prevent this, we can fix an object in place that specifies the alignment of the y-axis of the moving parts with a reference frame attribute. It's also possible to determine an indirect alignment. For example, this is required for both of these bars. These must be rotated so that the second arm always arrives at the lower link. First, we want to properly rotate the upper bar, so we define the local reference point attribute. As with a normal cylinder, we can define the second part with a reference point. In the next step, we need to define the dependency between the cylinders. We add the dependent part elements to each of the cylinders to say that this object must also be updated whenever the first object is. The dependent part should then also only be updated once the first object has been updated. The last part for the cylinders are the moving tools elements. For performance reasons, not all cylinders are always updated. Only those cylinders will be updated where the relative position of the reference frames in relation to the moving part has changed. These triggers are the moving tools. So we now have a moving tool with the index attribute, which points towards the rotation node of the lower link. Finally, we add another dependent part, which points to the first of the two rods, so that they will be updated when the lower link moves.